Our first problem with multiplication with polynomials is really just an application of the distributive property. We want to multiply 4a cubed times 3a squared minus a plus 1. By the distributive property, we know that will be 4a cubed times 3a squared minus 4a cubed times a, that's that term, plus 4a cubed times 1. So you can see by the distributive property, I've distributed that 4a cubed across this sum and difference here to each term. Now multiplying here, I have 4 times 3 is 12. A to the, I add exponents, 3 plus 2 is 5, minus 4. A to the 3 plus 1 is 4, plus 4a cubed times 1, which is 4a cubed. So there's my product, 4a cubed times this trinomial right here, and it was simply a matter of applying the distributive property. Let's look at the product of a binomial with a trinomial. What we want to do when we multiply this binomial times this trinomial is multiply each term here times each term here. We can do that in a sort of organized fashion by writing the 2a minus 3 underneath and then using something that looks similar to long multiplication. Let's try 2a times 3a squared. When I do that, I'll end up with 6a cubed. Now 2a times negative 5, negative 10a squared. 2a times 1 will be 2a. That takes care of this term 2a times each of those three terms. Next I'll go to the 3 and I'll take the subtraction sign with it, thinking of this as plus a negative 3 times each of these three terms. Negative 3 times 3a squared will be negative 9a squared. I'll write that underneath the term it's similar to. Negative 3 times negative 5a, positive 15a. And negative 3 times 1, negative 3. So I've lined up similar terms. Now I'll simply add 6a cubed minus 10a squared plus another minus 9a squared will be minus 19a squared. 2a plus 15a, 17a minus 3. So here is the product of this binomial with this trinomial. And the rule is really multiply each term here times each term here. This is just a method of accomplishing that, which looks similar to long multiplication with whole numbers. Here's our next example. I have this binomial times this binomial. I want to multiply each term here times each term here. So I'll start with 2a and multiply times 3a. That will give me 6a squared. 2a times 2 will give me 4a. Now I'll move to this term and multiply 3 times 3a. That will give me 9a. And then 3 times 2, that will give me 6. Now combining similar terms, I have 6a squared plus 13a plus 6. So here I've multiplied each term in the first polynomial with each term in the second polynomial sort of in a linear method or in a straight line like this. I could have used the column method that I used on the previous example also. Let's try one last problem. X minus 2 quantity cubed. By definition, this is x minus 2 times x minus 2 times x minus 2. So let's multiply x minus 2, that's this, by what I get when I multiply these two together. X minus 2, I'll have x times x, which is x squared. The last term will be positive 2 times, negative 2 times negative 2, which is positive 4. And the middle term comes from these two multiplied together plus these two multiplied together. So that's negative 4x. Now I need to multiply x minus 2 times this. So let's do this in a sort of a column arrangement. X times x squared, x cubed. X times negative 4x, negative 4x squared. X times positive 4 plus 4x. Now, negative 2 times x squared, negative 2x squared. Negative 2 times negative 4x, positive 8x. Negative 2 times positive 4, negative 8. So here's my column arrangement again. Now I'll just add similar terms and get x cubed minus 6 x squared plus 12x minus 8. So there is the answer to the quantity x minus 2 cubed. It'll be x minus 2 times x minus 2 times x minus 2. And that's a look at some problems that involve multiplication with polynomials.